All right, everybody, so our next video here is focusing in on what happens when we have a set of numbers that does not have a common difference. So we're not adding or subtracting by the same thing every time. What do we do? So say, for instance, we have something like 0.5, our next number is a 2, then we go to 8, we're all the way up to 32. So if we look, our difference here is like 6, our difference here is quite a bit more than 6. What is that, like 24? Not the same thing. So to be clear, first, not a same common difference. So not a common difference. So this is not an arithmetic sequence. So what can we do with this? Well, we do have a second type of sequence. It's called a geometric sequence. And this is a sequence where, or a sequence with numbers where consecutive terms have a common ratio. What that means is if we take a term and we divide it by another term, it should have the same answer every time. So let's see. So for the first one, if we do 32 divided by 8, we get an answer of 4. If we do 8 divided by 2, we actually also get an answer of 4. If we do 2 divided by 1/2, to punch that one into the calculator, we'll also get an answer of 4. So if we divide consecutive numbers, and we always get the same answer, we call that our common ratio. And we write our common ratio as R. So that's going to be R in a geometric sequence. So pretty similar notation to an arithmetic sequence. A given number in a series, or A subscript n, is the first term, or A subscript 1, times that common ratio to the n minus 1 power. So how this works is we basically just take a look at our sequences and we plug some numbers in. So if we look at our sequence up here, we have a common ratio of 4, because when we divide, every single time we divide, we get an answer of 4. And our first term is 0.5. That's literally the first number in our set of numbers here. So when we're plugging this in, a to the n equals 0.5 times our common ratio of 4 to the n minus 1 power. And that's how we would write that out. So just like we did before, let's test out a number. So let's say that we do this for the third term. So we'll have 0.5 times 4 to the 3 minus 1 power. Okay? So first, Pemdas. So parentheses come first. So 0.5 times 4 to the second power. Okay, next we need to do exponents. So 0.5 times 4 squared is 16. And then we'll have 0.5 times 16 as our last step, which gets us 8. So our third term is 8. Is that true? Let's scroll back up. And hey, look. Term 1, term 2, term 3 is in fact 8. So that works for these sequences. We can plug in basically any value, any string, even up to like 1,000, and we'll know the 1,000th number in this sequence is going to be by plugging in 1,000 for n. So a few types of questions that you should be prepared to see in these situations. We'll go over one of them here. So they might give you, let's say, the fourth number in a sequence, and they'll give you the common ratio. And just like before, you are going to have to solve. So always, always, always start off with that formula and plug in everything that you know. So we don't know this, but we do know R, and they're giving us a term. So we don't know this, but we are given this, and we're given this. So 5 equals a to the 1, subscript 1. Our ratio is 6, and then it's our fourth term, so we're going to plug in 4 for n. That's our n right there. Okay, so let's just go through, do some PEMDAS. So 5 equals a to the 1, 6 to the third power, So 5 equals a to the 1, and then 6 to the third is calculator time. 6 caret 3, 216. Okay, so we have a to the 1 times 216, so divide by 216. And we'll get our first term is 5 divided by 216. So let's actually leave that as a fraction. Have some messy rounding there otherwise. So if we look at this, we just solved. We're happy. So we basically plugged in things that we knew and solved for the things that we didn't. So we can, once more, go ahead and write out this full sequence. So a to the n equals 5 over 216 times our common ratio of 6 to the n minus 1 power. And that is our fully defined geometric sequence. So for today, you're going to be asked to define the geometric sequence. You might be asked to solve for the first term. You might be asked to solve for the 10th term. And again, you are just plugging in n values in that case, but using that same formula. So a big emphasis for today is these formulas. Using them, plugging in, getting comfortable solving for unknowns within them. As always, everybody,